the exam, and I thought, what's the rush? Let's do this exam on structures, and that's all. So just we're going to make sure, well, I mean, I hope you're going to make sure you know structures well. Like I said, I think it's sort of the key to this class is structures. So you have the practice problems and solutions you need. Today we're going to do a structure that has, like in groups, step by step, we're going to do a structure that has more than two members meeting at joints to make sure that you're straight on the way you have to deal at the joints, like what members touch what members and stuff. And yeah, that's all. So no internal loads on this exam. Okay. And it is Tuesday, right? I forgot to look. Did Okay. It is Tuesday, yeah. What? Okay, the second. So yeah, that makes sense, right? Yeah. Um, okay, so that's the only topic. Um, and so just make sure that your free body diagrams are, you know, follow all the rules that I told you about free body diagrams. Make sure anytime you use Newton's second law or rotational Newton's second law, you have an associated free body diagram. Okay. Um,
Will there be any 3D on there?
no, no 3D. It'll all be 2D. I mean, probably there'll be one thing like the problem set probably, and then the rest will be 2D. A little bigger, probably a few more members. Yeah, yeah, exactly. Actually, 4D. I'm probably going to do a 4D structure.
I'm not good at drawing 4D. It always looks like a unicorn.
You can do the statics of a Klein bottle or something. Remember that? Um, okay, so um, if you if you can do those practice problems, you're in good shape. So don't don't look for curveballs. Get ready for fastballs. Um, so today, let's just do this example. Any questions about the test before? Okay. Um, uh, and there's a 5,000 Newton force applied at this pin, 5,000, and a 5,000 Newton force down at the midpoint of this member. And let's number the members 1, 2, 3, 4, 5, and then the joints A, B, C, and D. And each member is 1 meter long, so these are all equilateral triangles. And the problem is to calculate the external loads on each member. Okay, so the first step of this problem is Isolate the whole thing. Yep.
If there's no mass, right?
Right, we're going to neglect gravity on this. And after the exam, I'll do a little bit about how to, I'll talk a little bit about how to treat, so if we had weight on all these, it would be easy to calculate the external loads. Things would get a little weird though when we went to calculate the internal loads on each member. Can you think why that would be? What would make that complicated? Because we've done internal loads. It's distributed load, and what's weird about the distributed load? Because we've done internal loads with distributed loads. Okay, what's weird about it is the distributed load on these diagonal members are like this, right? So when we do the rotation, we'd get the distributed loads are these vectors. They're not just vertical. You know what I mean? So that it's not that hard to deal with, but it's something we haven't done yet. So we'll talk about that after the exam. Okay, so first we have to isolate the whole member, the whole structure. So do that, talk to each other as you go, and when you're done, I'll do it up here. And we're just going to go through it member by member. You'll do it, we'll do it up here, and just make sure you're on the same page. Oh yes, thank you. Yeah, let's use the coordinate system like this. Okay.